Now let us talk about abstract data types. If we look back, what we have been doing with this linked list, what we have been doing, we have been adding an integer n to that list. We have been removing an item from that list or printing all the item in the list, that is, we were traversing. If all we care about is being able to perform these three operations, that is, add, remove and print, it does not matter so much whether we implement them using linked list or perhaps arrays or vectors or any other data structure. What we really intend in any data structure that stores data internally and allows us to use these three operations, namely add, remove and printing or traversing. In other words, what I intend to say is we focus on what we want to do, these three we want to do, and not how exactly it is done. Linked list is one of the answer to how. Means what we want to do, we want to have a data structure where we can add, where we can remove and where we can print. And what are the options? The options are, one of the options are linked list. So let us be precise about this what. That is the operation we want to implement, or by implementing is what is specified as an abstract data type. So abstract data type, we are searching for what? The operation we want to see implemented or are implementing is what is specified, and these three were our basic operation that we intend. So now this ADT is defined entirely by the operation it supports. Okay, not by the data structure we are talking about, but by the operation it is going to support, such as the ones which we just discussed. And we'll see about this ADT more. List. What is a list? A list is a data type which is defined by supporting the following key operations. What are the key operations? In this T denotes any type such as integer, string or something else, or any data type. So inserts the value right before the given position, moving all later elements one position to the right. What is removing? We are trying to remove at certain position the value at the given position, moving all later elements one position to the left to fill in the gap. Then setting. What is the setting? We have a position and a t value. It overrides the given position, this position, with the given value. So t, this any type t, this value will be overwritten on this position. So this t get what it returns? It will return the value at the given point. So these are various operations. The list data type is a lot like an array in its functionality. Those who are very good at in programming, mostly OOPS programming, they might be knowing what I am speaking about list. So this list data type is not like an array in its functionality, but it allows inserting and removing elements while shifting all others. Shifting is possible. But this definition, it does not tell us what values of position are legal or what happens when they are out of range. This is not being told. Let us take an example. If I am trying to insert something right before position 4 of a 2-element list, what should happen? 2-element list you want to insert before position 4. Should an error be signaled? Should the list be filled up with the dummy elements to make it possible? We hadn't said what the legal ranges are of the position variables for the other operations. So these are some concern. So here what we intend, that position needs to be between 0 and size -1. If you are talking about 2, it has to be only 0 and 1, means 2 minus 1, that is 0 and 1. Where this size is the number of elements in the list, and for all operations except insert, where it needs to be between 0 and size, right? We could add other functions that should be supported, such as size or isEmpty. So these are the things which are getting elaborated. So we are possibly familiar with this C++ vector. We have talked about vector a lot. And DQ also, this is DQ, a form of Q. And this DQ data type and C++ vector, which are two natural implementation of the list data types. And they provide a lot of functions also. Then comes the bag. What is this bag? Or a set. So a set supports or should support following operations. What are the operations? First is add, that is add the item into the set. Then remove the item from the set. Bool contains, that is it returns whether the set contains the given item or not. This is a trivial implementation of the mathematical set. For instance, our implication or specification, we do not say what should happen if an item is added multiple times. In a set, if we have multiple addition, what are the action we need to take? Or multiple copies added, or only one and is an error signaled. So if multiple copies are added, then what does remove do? Does it remove just one of them or multiple? So we only allow one copy actually, and we want to allow multiple copies of the similar item. Then we will call it not as a set or a bag, but a multi-bag or multi-set. Then the dictionary, which is called a map, and where mapping is there, we'll have some key and values. So a map or a dictionary, this is a data structure for creating and querying association between a key and a value. Creating and associating key and value. So these both keys and values, they can be arbitrary data types, say key type and value type themselves. And they may support, or they should support, add, that is key value, a key which is a key type, value type is value, so key or value. See, this adds a mapping from key to value, and remove means removing the mapping from key. Value type get what it does, it returns the value from the key, maps to, and again this is a we need to specify it more. What happens if a given key is not in the map? What should remove and get do now? These things are always your purview, and perhaps you have to really see what you need to do. Will they signal an error? Also, if another mapping is added for the same key, what is going to happen? Can two mappings coexist? Will an error be signaled? Does the new one override the old one? That is, one would not allow coexistence of the mapping from the similar key. But there are commonalities also and differences also between these abstract data types. What is that? Let us see the first one. All of them support storing data and accessing them. After all, what are they? They are abstract data types. And the difference between a list and the others, we have just seen list, is that list really cares about the order. It really cares about the order sequence. So a list in which the number 2 is in the position 0 and the number 5 is in the position 1 is different from the list in which the two numbers are in opposite order, right? So order is important in list. While in a set or a map, they don't care about order. And the element is either in a set or not, but there isn't even any meaning to such a thing as an index in a set. There is no index in a set. In the same way, element maps to others under a map. We have seen mapping, but there is no sense in which the elements are ordered. Again, we are not concerned with the order here. Let us see with all these discussion with some application of these data structures. How a list. This may be a good thing for such a thing as a music playlist, like lines in a computer programs or the pages of the book. In all of them, the order of the items is very important as the ability to access specific items by index, right? While a map, what can it be? It is a natural fit for any kind of directory. For example, student records, email addresses, phone books, directory of words, web page lookup by search query. It doesn't matter in what order the items are stored, as long as it is easy. Given the key, you find the corresponding record. While in the list, which is fundamentally different from the map in various terms, a set is actually quite similar to map. How? The difference is that for a map, we store additional information of each item that we store, whereas in the set, we only remember the presence or the absence of the items. So this was abstract data types for you. Thank you so much. Take care.